Agreed. Now, so what is telling? At a distance 3r, a negative point charge with what minimum velocity it should be projected so that it can reach the center of the ring. The one basic condition is what he has given. This is the axis of the ring, from where it should be projected from the axis of the ring. Okay, so that it should reach the center of the rings are fixed. The rings are not free to move. Okay, how to get this one? So now, shall we apply conservation of mechanical energy between these two? Now, before that, check the field. What about the field in this region? How do it will vary here? So let's pick up some point. So let this be at a distance x. Let's calculate the electric field strength at point P. Then we'll come to the discussion. So that should be equal to, due to the positively charged ring, kqx by root of r square plus x square. Okay, this is like this, no? Okay, due to positively charged ring, okay, we'll call this as 1, this ring as 2. Positively charged ring, let me give the number 1. Negatively charged ring as number 2. So the field strength here will be E1 will be like this, or I'll use that specific colors, will be easy for you. This will be the E1. Then due to negatively charged ring, E2 will be like this. I need another color. Hello, yeah. Hope you are able to see that yellow color. So how these two fields will be in opposite direction. So therefore I should take the vector sum. So then this will be K or one step, I'll write it. What is X? X is the at point P we are finding out. This should be equal to radius of the larger ring Now look at this one. So let me check, is it 0 anywhere? Let me solve it. This one. Is it 0 anywhere? So if I solve it, kqx will get, so this will become kqx r square plus x square to the power of 3 by 2, 8 equal to 8 kqx 4r square plus x square to the power of 3 by 2. So what will get eliminated? kqx will get eliminated. So we have this one. So solving this, I'll end up with x equal to 2r. Field will be 0. The net field will be 0. So in this region, let me put some boundary. In this region, the field strength will be directed in this way. Got it? As it's a negative charged particle, what you are projecting, the field will be in this direction. In this region, the field will be in this direction. E dash, E double dash. So I'll call this will be like a repulsive. This will be attractive. Any reason for that? Because see, here if it's 0 means on this side, the field should be attractive. Attractive in the sense open will be directed towards right. Here the field will be directed towards left. Because here I got 0. No, the negative charge particle in what direction will experience a force? Towards right. Once it crosses point P, then it is going to experience an attractive force. I need not to do anything. This attractive force, what happens, we'll see that the charge particle will easily reach this particular point. Getting the idea? So I think I'll explain through diagram, because you find very difficult. I'm trying to put everything in one diagram. You may find difficult. Only I need rings, no? With some suitable diagram, let me explain. So this is a point P. If charge particle is here, it will experience force in this direction. If the charge particle, when it is here in this region, it will experience force, repulsive force it will experience. Getting this one, the reason for that, because the net field at a distance less than 2r. Oh, yeah, we have this one. Okay, this is that negative charge particle. So what this charge particle is going to experience, negative charge particle will experience a force opposite to electric field. Negative charge particle will experience force opposite to electric field. So here when I project it, it will undergo retardation. Somehow, if it can just reach point P, afterwards on its own, the net field here will see that it will get accelerated, it will reach point O. So now, with what speed I should project? I should project with the point A with such a speed that if it can just reach point P, that'll be sufficient. So what is the idea now? What is the idea of the main? There's a main idea of the problem. The point charge minus Q should be projected with the speed so that it just reaches the point P. That is enough, huh? With the speed so that it just reaches the point P. From where? From here, I should project with this minimum speed. So now I should apply the potential conservation of mechanism between point A and P. The problem will be solved. I need not to talk about the point O. So for that, we should calculate the potential set point A and B. So now who will do the electrostatic force will do work. And if you can recollect, we have derived some equations, no? Work done by electrostatic force in moving a charged particle. Work done by an electrostatic force in moving a charged particle from 1 to 2. Should be called Q V1 minus V2. So let me apply the thing that one. So work done. So initial kinetic energy at A plus work done by electrostatic force in moving a charged particle from A to P should be equal to final kinetic energy at point P. Initial kinetic energy supplied of V minimum square. Work done in moving a charged particle. So that should be equal to charge particle into VA minus VP. Finally, this should be equal to 0. Potential at A minus potential at B. And as there's a negative charge particle, let me introduce that sign here. Okay, further simplification of this will be what we should calculate: potential at point A and potential at point P. Let me have all these things here only. Potential at point A due to each ring. So K Q by root of R square plus 3R whole square plus K minus 8Q root of 4R whole square plus 3R whole square. Potential at point A. Similarly, potential at point P is how much? KQ by root of R square plus X square plus K minus 8Q root of where x equal to 2r. Substitute all this. After substituting all this, you'll get an expression for this one. You have to substitute that V and VP here. Solving this will end up with V minimum. I'll shift it down. Okay, no, you have seen, no? Let it get saved. Where x equal to how much? 2r. We have to substitute these things in this equation. So solving that, I'll get the expression for V minimum as a little bit lengthy. Please do KQ by R 6 root 5 plus root 10 minus 16. This is your answer. So there's a simplification part. Okay, the main idea is this one. So just directly from point A to point O, you should not apply. That's what it's telling. From point A to point A, don't apply. So check the field variation once. Without this potential, I think you have to struggle a lot solving this one. The force will be acting. Look at the force will be variable. Then you have to integrate. The potential idea is very much beneficial. No, that's what the essential of studying the potential. It will simplify our calculation part. The potential concept will help us to easily conclude a problem. Otherwise, we should take care about the mathematics. Every mathematics will come. Your force will be there. You should know the nature of force. Then you have to integrate. A lot of integration will come into picture. To minimize that mathematics, we are taking help of this potential idea. Why minus Q? If the positive charge plus Q, negative charge minus Q. Let me